So you're probably wondering who this German-American economist is, Vasily Leontief, and he was known for solving some of the economy's biggest problems. And it stems from determining how much does each sector rely on inputs from other sectors. In fact, how does the output of one sector serve as inputs for another? Well, we need to create some kind of model that serves as a way to understand how different sectors in the economy depend on each other. If we can show how much output each sector produces and how much of the output is used as inputs by other sectors, we can use that as leverage, a crutch, to help economists and policymakers analyze the interdependencies and predict the impacts of changes in one sector on the rest of the economy. And what's one model that awarded this man a Nobel Prize? It turns out it's very similar to a Markov chain. So let's say we're given this matrix, and this is what's called as the input-output matrix, where each entry denoted as D is the amount of output that the industry needs from each entry. And yeah, this is pretty much how we're able to determine the interdependencies between different sectors of the economy. And the I and J subscripts can denote how much of what each industry needs from each other. And as you can see, we have the outputs and inputs. So to understand this, let's say D sub 12 was a numerical value, and we were to let D sub 12 be 0.4. Now, based on your understanding from Markov chains, what does this mean? How can we interpret this? Well, when D sub 12 is equal to 0.4, this value means that for industry 2 to produce 1 unit of its product, it has to use 0.4 unit of industry 1's product. So let me put it in percentages. In order for industry 2 to produce 100% of its product, it might use 40% of its resources from industry 1's product. Now, let's say we were to have D sub, let me scroll down. Let's say we were to have D sub 33 equal to 0.2. What does that mean exactly? Well, it simply means that industry 3 needs 0.2 unit of its own product to produce 1 unit. And in percentages, it needs to use 20% of its resources to produce 1 product. Now, of course, there is one thing you gotta remember here, and it stems from the question: why are these in decimals, not whole numbers? Well, in order to utilize the input-output model, the matrix has to be stochastic. So that's one pointer. Well, that's one additional pointer when it comes to these models. And that's pretty much the fundamental of the input-output models. Thank you for watching, guys. I hope this was brief and concisive.